All right, when solving a system of equations by graphing, it's easiest if both equations are in slope-intercept form. Okay, and if you don't remember which form that is, y equals mx plus b, your favorite. So we're going to graph these, and then we're going to see what happens. So remember on A, right, this first one, if you have two colors, you can use two colors. If not, you can just label them. So we're going to start down here at -1. We're going to count our slope, rise 2, run 1. You can do that multiple times if that helps you with your line. But when you do the second one, you have to change it first, right? On our last test, we had that question. You have to change it to slope-intercept in order to graph. You cannot graph from standard form. So we're going to move the x. We're going to divide everything by that number in front of y. So y equals 2x plus 2. So now I can go up to 2. This has up to over 1 also. I've run out of space, but I can go down 2 and back. Oh, what do we notice? Parallel. They are, in fact, parallel. So I'm just going to jump down to A real quick. What does this mean? Okay, so since these lines are parallel, because they have the same slope, they're not going to cross. My pen does not want to write today. So there is no intersection. All right? So we get y equals -1x minus 2. Oh, does anyone notice anything? Okay, they are the exact same line. So since they are the same line, instead of having no intersection, they are all intersecting. Okay, so we're going to talk about what that looks like. So yesterday in the intro piece, it talked about one solution. One solution is where lines have different slopes and they intersect at one point, okay? We can plug that xy coordinate into those equations. It will be true. So we have no solution if the lines have the same slope and different y-intercepts. Remember, if they have the same slope, they are parallel. And since they are not intersecting, they have no solution. We have infinite many solutions if they have the same slope and the same y-intercept. They are identical. If they're identical, they have infinite solutions because every single point on that line overlaps. Does that make sense? All right, let's look at example 1. All of the answers are on the PDF in the calendar. I'm just not going to do them all on here. So we're going to start at 4. And our slope is positive. Please, please be careful with your positive slope and your negative. I have some people that are really getting those confused. So here's our line. Try to draw it as straight as you can because we are looking for an intersection. And again, we have to change this to y equals. So now we're up here at 7. We're going to go down and over. Oh, look how pretty that is. So what is that coordinate? 2, 5. So what does that mean? That means if I put the 2 in place of the x and the 5 in place of the y, and I put that in my calculator, it would tell me true. If I put the 2 in place of this x and the 5 here, it would be true. So when we look at number 3, what do we notice? Can we do anything yet? No, we got to change it first. Okay, so We're going to minus that 3x. This is just the more of the same. It's good practice. Divide. Now, if you do not do this correctly, then you can't graph it correctly, so be careful. Negative 1/2 x minus 2. And then I'm going to go ahead and I'm going to divide on my second one because I just want to go ahead and graph all at once. So y equals, this is, oh, look at what happened here. Negative 1/2 x minus 2. What do you notice about these two? They're the same. They're identical. So since they're identical, what does that mean? They intersect infinitely, right? I cannot spell today. Infinite solutions. We don't actually even have to graph it because we know that they're going to be exactly the same. All right, so if it's no solution, we need to know that the slopes are the same or different. Slopes are equal. Okay, so let's find the slope here. What is it? Negative 1/4. And the b on this happens to be 3. Now, if we want it to be parallel, can you give me an equation that is parallel to that? Negative 1/4 x plus 1. Any negative 1/4 x, as long as this b does not equal 3, you can put any equation you want. So on this one, after you convert them, you should get Ravi and Courtney because infinite solutions means that they are identical. So the last one I want to do real quick is this word problem. Yeah, you can convert this, and you can put this in Desmos and look for that point of intersection. So this would be y equals negative x plus 9. You've got 2x minus 3. If you wanted to graph it by hand, you could. If you wanted to use Desmos, you could do that as well. If you graph it by hand, you need to make sure that you are... Oh, nobody caught that I did my slope wrong on that. 1, you have to do your slope correctly. I went down for some reason. I don't know why. Because I'm human and I make mistakes, right? If you do this by hand, make sure that you draw very carefully, which I did not do, which is why checking it in Desmos is a handy thing. If I zoom in here, if I go up to and over 1, it's actually this one. I was off. So what is it? 4, 5. And if you look at the word problem, 4 is our x, and that is going to be streamers. And 5 is going to be y, which is balloons.